Hi everyone, this is connective tissue, proper, dense connective tissue. So I hope that this flowchart helps you to keep everything in place. We are gradually working our way through connective tissues, so we're getting there. And in talking about connective tissue and dense connective tissue, the function of this dense tissue, is to bind body parts together like um, like shoulders and knees, for instance, and like aortas to hearts, big, important, very high stress body parts. And this dense connective tissue allows recoil and really withstands that tensile stress that it is under. Very highly specialized tissue. Of course, it's divided up. And dense connective tissue divides into regular and irregular. And so we are going to be studying regular, dense, connective tissue proper right now. And along with withstanding that tensile strength that it's so well designed for, this regular connective tissue also attaches muscles to bones and tendons. Remember the 10 muscles of Don, right? The tendons. And it connects bones to bones with ligaments. Remember the tibula and the fibula lie next to each other, and those are ligaments. So this is what we're talking about, tendons and ligaments. We're talking about dense, regular connective tissue. Let's take a look at it. As you can expect, this is very dense tissue. When you are looking at these slides, you're not seeing any environment here. This is dense tissue all the way through. When we look at it, we're looking at ligaments here, and we're looking at tendons here, right around the shoulder. So a lot of this dense regular connective tissue in that area. When we classify it by cells, cells are all fibroblasts. And remember, the nuclei are right in the shape of the fibers that they are developing. So the fibroblasts are creating the fibers, and they are falling right along the shape of those fibers. And of course, the fiber that we're talking about is collagen. So this is really well documented for your dense regular connective tissue. And we have not only one but two kinds of dense regular connective tissue. There's also elastic connective tissue, which is really important because it connects your aorta to your heart. Pretty important. So not only that, but it is using the function of withstanding that tensile strength and putting in the recoil strength for the contraction and the relaxation that's noted around the heart. And when you take a look at this, look at what we're talking about here. These are elastic fibers rather than collagen fibers here, and that's really all you're seeing. That's how specialized the heart tissue is. And I wanted to point out to you, here's the environment, because this is the heart wall right here. So this is the environment right along the wall of the aorta. When you see these all linked together, think about elastic, connective, dense tissue. It makes sense. Now, to go back to dense connective tissue, irregular, that is still withstanding tensile strengths. The difference is it's doing it in many different directions. So these cells have to be in irregular patterns to handle all these different directions. By placing these fibers in many different directions, we're adding structural stability to this tissue, which is dense, regular connective tissue. Where do we see that? We see that in an area that has a lot of different angles for these tissues, and the knee is a perfect one for this. So this is a fibrous joint capsule that could be around the shoulder, a joint capsule, not necessarily a ligament or a tendon, but a joint capsule that can be around the shoulder or around the knee. This is dense, irregular connective tissue for all the different movement and all the different angles. When we're looking at this, when we're looking at cells, we're seeing, of course, fibroblasts, but we're not seeing them elongated in the collagen fibers because we're going in so many different directions with these collagen fibers. Some of them these collagen fibers are in one direction. Many of them, look, are at a 90-degree angle, and many of them are at a 45-degree angle. Many different angles for these fibroblasts that are in there for the collagen fibers. And when we look at the extracellular matrix and the fibers, that's what we're seeing, irregular collagen. I'll see you on the next video.